All right, so before I get into the heat equation and all that, let's take a second more here to do this problem with the method of Laplace transforms. I think it's good exercise for us all. So let's see here. So we use big X and big Y for the transform variables. So we get S times big X, and then minus x of 0. But x of 0 here is 1, so minus 1 is equal to minus 2 times big X minus 5 times big Y. All right, then dy dt, transform of that is S times big Y minus 0, right, which is that, okay, equal to big X plus 2 times big Y. Well, that's not too bad, right? We can take the second, so let's call this equation 1, equation 2. So we can solve 2 for x. X equals to what? It's S minus 2 times big Y, right? Then plug into 1. What's that give us? It gives us S times S minus 2 big Y. Schnikes. Sorry, let's clean up one. Let me clean up one before I do that substitution. Otherwise, I'm just being dumb. All right. So cleaning up one, what's it look like? It's really S plus 2 times big X equals to what? Equals to 1 minus 5y. I mean, you can clean it up other ways, but I just wanted to consolidate all the x terms together. Yeah. Okay, so then plugging, take this and put it up in there, and we get S plus 2 times S minus 2 times big Y equals to 1 minus 5 times big Y, right? Also known as S squared minus 4 plus 5 times big Y equals to 1. Oh, that's nice. So Y is 1 over S squared plus 1, right? So what's little y? What is it? What's the inverse transform of 1 over S squared plus 1? Yeah, just sine of t. And then, of course, then at this point you could go and you could, go back to, what was x? What was x? S minus 2y, right? So that's S minus 2 over S squared plus 1. So you take the inverse transform of that, you get x, little x, is equal to cosine of t minus 2 times the sine of t. Of course, well, yeah, I guess that's what you want to do. The problem we worked before was nice, and like that one of the solutions was the derivative of the other. This isn't quite that way, so it actually makes sense to go back and sort of do the algebra to find big X and then inverse transform to find little x. But there you go. That's the solution we found using the eigenvector technique with the initial conditions already rolled into it. Yeah. What do you guys think? You're like, we admit nothing? You're giving me showing me no weaknesses, anything for me to work with as I construct your test. So fun. All right, so as silly as it is, hit stop and then hit record again. So I have a clean break here.